Hello, everyone. My name is Thomas Melrose. I am the Customer Marketing Manager here at Teletrac Navman. You might be familiar with my work. In all likelihood, you've probably deleted it from your inbox. I send you guys a customer newsletter, give you information about software updates, new products, things along those lines. Very good stuff you're interested in seeing on a daily basis. Also on the call is LJ Burnaby, an invaluable member of the Teletrac Navman marketing team, and our guest of honor, Alan Getz, who will be driving the presentation about vehicle electrification. I just want to open by saying this is a very exciting time for me. This is the first opportunity I've had to present in front of an audience of 10,000 people before. Okay, in all likelihood, there aren't 10,000 people on this call, but there's a large population of you out there. So we're very grateful for you guys to join, especially in light of what's going on out there with the virus and whatnot. I'm not a doctor, I don't know. So now you also may be asking, Thomas, how did we go from a webinar about AI and cameras to vehicle electrification? Well, that's a very good question. I'm glad you brought it up. Thank you. What you may or may not know is Teletrac Navman and Gilbarco Veeder-Root, for that matter, are part of a larger organization called Fortive. And under Fortive are these different companies that work in different spaces and whatnot. And sometimes we get to interact with each other. Sometimes those interactions produce content and synergies that we thus share with the customer base, you good people. So moving on, a couple housekeeping issues before I defer to Alan. So audio. Hopefully you have the audio portion situated already, because if you don't, you're not going to hear anything, and you certainly haven't heard me, which might be a good thing for all intents and purposes. Secondly, the webinar is being recorded and will be sent to all attendees. You'll also get access to the webinar presentation deck as well, so don't worry about that. And then finally, the questions. There's a question section in the GoToWebinar widget. Put your questions in there, and then we will address them after the presentation is completed. So on that note, I defer to Alan. Take it away, good sir.
Okay, great, thanks. Well, first off, let me say thank you to everyone who's an attendee out there in today's world. So appreciate you making yourselves available for the session. I've pulled up some slides and a quick introduction of myself. Just wanted to turn on the webcam for a brief moment to say hello in person, since we can't have these kinds of meetings face-to-face like we're used to. Turn the webcam off here. So a little of my background. I've been in the fleet industry for almost 15 years now. Worked in a variety of different roles, from the fueling side of operations, certainly software as well. This has been a global career for me, and I'm certainly excited to be close to 2.5 years now on the Gilbarco Veeder-Root team. So maybe a little bit about who Gilbarco Veeder-Root is. As Thomas alluded to, we are certainly part of a global organization called Fortive. Fortive is a Fortune 500 company, and they've got a division focused on industrial technologies. And so that makes Gilbarco Veeder-Root very much a sister company to Teletrac Navman, very much located around the world, with our headquarters in Greensboro, North Carolina. When we think about where we do a lot of business with fleets, we're very heavy in the government space. We're also big in trucking, construction, rental cars. So quite a heavy number of vehicles use our technologies throughout the day. And on the left-hand side of the screen, we make everything in that picture with the exception of the tank. So very, very heavy in the fleet space, and super excited to talk about these topics today. Customers of ours include, utilities, government agencies, large trucking companies, and so on. So really some exciting customers in the base. And to talk now a little bit about kind of the history of electric vehicles. Most people don't know it, but America was actually an EV country before we were a gasoline engine country. The first EVs were lead acid batteries. They had very short ranges, but at the time they were the best technology could offer, and certainly a viable replacement for horse and buggy. The country really pivoted to gasoline vehicles whenever inexpensive oil was discovered in Oklahoma and Texas, and then the invention of the electric starter instead of a hand crank really signaled the pause for EVs up until the modern period. For those of you who've been in the fleet space for a period of years, if you were like me and were working in the industry in 2008 when the bottom fell out of the economy, fuel prices skyrocketed, and a lot of fleets were left struggling to try and cover their fuel bills. This slide speaks to the cost of electricity as being kind of low and steady and stable as a fuel source over a significant period of time. So this is a great way to kind of talk or prime the pump when thinking about e-mobility and fleet electrification. Perhaps 10 years ago, when Nissan first launched the Nissan Leaf, people had a mindset that electricity in EVs was just as dirty as running a gasoline or a diesel vehicle. In today's terms, the utilities have really broadened the stretch of the power and the sourcing of the power that they bring to consumers, whether that's commercial or household. And so the addition of solar and wind and hydroelectric has really made the grid less reliant on dirty coal power. Even coal itself has gotten significantly cleaner using technology. This slide speaks to what the mile per gallon equivalent would have to be for an ICE engine, a gasoline vehicle, to be as clean as an EV in these different regions across the country. So we're seeing numbers on the screen that are virtually unobtainable with today's technology in the gasoline engine space. And so that certainly means EVs are cleaner today than any other option out on the road. So why electric vehicles? Really, we're thinking about fuel economy and mile per gallon equivalents, like what I just spoke to. The vehicles are very torquey. They've got a lot of pep. When you step on the pedal, it's going to push you into the back seat. The battery prices, it's a technology front that's continuing to get better, and the labor needed to assemble the vehicles is significantly less. The reason being that the vehicles have less parts. When there's less parts, that's also cutting down on total cost of ownership, which is a huge metric in the fleet space. And so even though the EV may be a little bit more expensive on the front end, on the tail end, through the life cycle or the duty cycle of that vehicle, it's less expensive to own an EV. So why now? Well, Tesla has certainly proven that EVs can be fun to drive. Volkswagen Dieselgate was a huge, huge influencer in what's happening. A lot of money has become made available for infrastructure projects. Really, the thing that I think is pushing EVs the hardest is that China said several years ago that they were going to leapfrog the rest of the world in the manufacturing of electric vehicles. Had an opportunity to visit Beijing about 3 years ago, and when I landed and got out from under the airport, you could tell it was a sunny day, but you couldn't see the sun in the sky in that city of 44 million people. It's so polluted that you couldn't actually see it. And so they've got a huge problem, and they're turning to electric vehicles as a solution. Now, if a global player in the economic space and a communist country says that they are going to dictate production of electric vehicles, if you're a major OEM, whether you're a sedan manufacturer on up to a Class 8 18-wheeler, suddenly you may have to pivot your strategy for electrification. And that's why we see so many electric models coming out in, this year, if it wasn't for COVID, perhaps certainly next year, a ton of launches in the fleet space. So why do fleets look at electric vehicles? Well, typically the average fleet has a fairly repetitive daily driving cycle. It's certainly more than a consumer, but certainly obtainable in the range and the makes and models of vehicles that are available today for the consumer space, and also starting to tip into the fleet space. So we're seeing a lot of market activation in refuse vehicles, port vehicles, buses, shuttle buses, and so on. Certainly on the municipal side, a lot of activity in the sedan space as well for motor pools or for other applications. So this total cost of ownership figure, that's big. Saving money in the overall life cycle of the vehicle is important. The reduced maintenance requirements, that's big. Zero emissions, also huge. There's a lot of push for sustainability goals that may be coming from the C-suite of executives at a private fleet, or from a local city council, or perhaps even state government dictating plans to move to electrification. So a customer may be left facing a lot of questions about electrification. And this is an important decision to make. What vehicles are available today? How much do they cost? What do the ranges look like? If I pick the wrong vehicle in my fleet to electrify, what is that going to mean for my bottom line? What are the financial impacts as we think about tax incentives and rebates? And how am I going to be able to prove to that city manager, or city council, state governor, or executive suite that I'm meeting their goals for electrification? Well, one of the solutions that we offer is an electrification study. This is where we can take data coming from a system like Teletrac NavMan and bring that valuable telematics data into an analytics engine to be able to predict what vehicles out of the fleet are excellent candidates for electrification. So we understand what the vehicles are doing today using information from Teletrac NavMan, and then run it through a model that understands what exact electric vehicles are available. Is this vehicle going to be replaced with a Nissan Leaf or a Nissan Leaf extended range? What's the price difference between those two models? So we understand the vehicles that are available. We also make predictions on the infrastructure needed to charge those vehicles effectively and calculate that into the economics model to show that this does make sense over the life cycle of the vehicle, while finally providing sustainability metrics through reporting that can be presented to show that you are meeting those sustainability goals. So that's a little bit about kind of who Gilbarco Veeder-Root is, why we're looking at electric vehicles today, how perhaps a fleet can get started. The next thing to talk about is our unique approach to software. So we have a software package called ECOS that stands for Energy Knowledge Operating System. And originally it was designed for use by fleets who have private fuel tanks. This certainly allows for the capturing of valuable metrics like driver unit numbers, odometers, and so on, including gallon information for fuel that's been dispensed. But we also tie that in with information coming from retail fuel cards. So if you're using a magnetic stripe card at a convenience store to purchase fuel for your fleet, we've got capabilities to tie that into ECOS as well, and can even get into monitoring fuel tank levels for fleets with private fuel tanks, and can assist in the purchasing of fuel from suppliers to arrange delivery and reconciliation for fuel. So that's very exciting, but in the EV space, you scratch your head and say, well, how does this apply? For a fleet that's got a private fueling location looking at electrification, the competition today offers a model where their EV information lives in a microcosm. ECOS has actually been designed to take input from a variety of different sources, and one of those sources is EV chargers. So if you're a fleet that has a private fueling facility and you're looking at electrification, you could pull up a single pane of glass, one user login, to see all of the transactional information for your fleet, whether that's going to be diesel gallons going into a box truck, or gasoline going into a sedan, or kilowatt hours going into a port vehicle, or a Chevy Bolt. That information can be broken down at the driver level. If you think about a motor pool application where someone may be in an Impala today and a Chevy Bolt tomorrow, that codes department employee still need to charge the codes department for the energy that was dispensed, whether that's going to be kilowatt hours or gasoline or diesel gallons. So ECOS allows you to track fueling activity at a driver level and also at a vehicle level. So that kind of reporting is, of course, mission critical when you're thinking about integrations into other systems like ERP systems or accounting packages or other customized software. So we're very excited to bring that ECOS approach to the market. On top of this, we're leveraging an existing brick and mortar distributor network to bring these products to market. So Gilbarco Veeder-Root, as I mentioned at the top of the presentation, we've got 60% of the market share in the convenience store space across the country. In addition, we've got a heavy presence in the fleet market. So we're leveraging those existing distributors and existing service technicians to take care of our electric vehicle customers who are purchasing charging infrastructure solutions from us. That's huge. Some of the competition is still trying to solve for service, and if you've ever been on the wrong end of waiting for something to be fixed, a mission critical piece of your business, you know how painful and disruptive that can be. So it's very important that I point out Gilbarco Veeder-Root has some significant presence in that space as well. So let's talk a little bit about charging. Perhaps a quick primer on what charging looks like in different types of charging available. So very common in the consumer space is AC level 1 charging. This is more or less the charger that comes with the vehicle. So this is a charging solution where you're going to plug into a standard wall outlet available at your house or in your office. This is going to deliver a pretty slow charge, but it's a very inexpensive solution, likely a great fit for consumers who are driving their vehicles 30 miles or less per day, who are probably going to park that vehicle from 6 at night until 6 in the morning and have plenty of time to slowly deliver energy back into that vehicle. The next step up is AC level 2 charging. This typically runs on the same energy that's available if you've got an electric dryer at your house, so 240 volt power. This is really a great fit for fleet type charging, where a vehicle is going to come back to a depot facility and again sit there for overnight. The biggest difference between the need for level 1 and level 2 charging is fleets typically drive more than an average consumer. So having the right kind of charger at your facility to bring that vehicle back up to full power through the course of a multiple hour charging session is mission critical. And finally, at the top of the pyramid is DC fast charging and high powered charging. This is where the duration of time for a charge is required to be very short, or the battery pack that is being filled is very big. DC fast charging, it makes a lot of sense for fleets who are looking to rapidly charge a vehicle, or perhaps a convenience store who's looking to offer an amenity for customers who are looking to charge. Makes a lot of sense for that convenience store owner to do this because the driver will likely come into the store and make an in-store purchase. On the fleet side of things, we really only see DC fast charge in fleets that are operating a large number of sedans or fleets who are looking to electrify big vehicles. If you think about a box van or a beverage delivery truck, or perhaps even a yard spotter or a regional delivery truck, those vehicles in today's market, the ones that are coming out, have 200 plus kilowatt hour battery packs. And some of these vehicles are operating duty cycles that require a very short period for charge. So DC fast charge can be a great fit for that space as well. Let's talk a little bit about our entrance into level 2 charging with what's called the amps-to-go charger. This is really the perfect charger for most fleet applications today. This is a rugged design unit. It's got a variety of different mounting configurations. It's relatively easy to install because most commercial buildings already have the 240 volt or 208 volt power needed to install this system. It's got a lot of flexibility when talking about networks or software options available, and includes a 1-year full replacement warranty. The amps-to-go charger has a lot of features associated with it. Certainly one of the ones that I think is important is the option to do smart card authorization or RFID authorization. So depending on what the application is, you may choose to have this charger basically be a free charger, where you don't care about tracking electricity dispensed. We would consider that perhaps a good solution. You've put a charger in at your facility and you're charging your vehicles. Perhaps a better solution would be to restrict access to that charger and also capture the information coming from that charging session. How many kilowatts were dispensed? How long was the vehicle plugged in? Again, we would consider that a better approach because now you're moving into smarter style charging. At the top of the pyramid is best, which would really, in our mind, be integrating in a private fuel tank through ECOS or a fuel card through ECOS in with on-site level 2 charging. Over on the right-hand side of the screen, you can see this unit is available as a dual port system, a single port system on a pedestal, or a single port system on a wall mount, with certainly options available for cable management as well. From the spec sides of things, I think I've already kind of covered what this looks like. This does come with a 1772 connector, which is really the most common connector for US vehicles and European vehicles. A person who's driving a Nissan Leaf in a fleet application can use a very inexpensive connector to plug into that 1772 port and then into the vehicle. So we do feel like this is a great fit for a lot of those fleet applications. Not that many fleets are running Teslas, but if you were, you would also use an adapter to charge a Tesla using this solution. So that's a little bit on our products and what we offer when we're thinking about the level 2 charging space. Let's transition and think about that DC fast charge or level 3 style charger. Oh, my computer froze up for a second here. There we go. Oh, back one. Okay, great. So several years ago, Gilbarco Veeder-Root made our entrance into the e-mobility space by making an equity investment in an Australian-based company called Tritium. Tritium is really the world's largest manufacturer of DC fast charge stations with over 600,000 sessions for charging. 33 countries, 3 global facilities, including one in Torrance, California, which is a suburb of Los Angeles. This really did get us into the market with exciting chargers to offer our fleet customers who do need a DC fast charge style unit. The unit that we're looking at on the screen here, this is a Veefil-RT 50. This is a 50 kilowatt charger capable of putting that kind of power into a battery pack over the course of an hour. Now, you may be asking yourself, how does that work if I pull up with a 30 kilowatt Nissan Leaf? So when you plug an EV into a charger, there's a handshake that occurs between the vehicle's battery management system, or BMS, and the charger itself. Basically, this is an opportunity for the vehicle to tell the charger exactly what kind of vehicle it is, what kind of battery it has, what the current state of charge looks like, and what the battery condition is. Once the charger receives this information, it's going to determine the appropriate charge to deliver to that vehicle throughout the course of the charge safely. So what that means is if you pull up in a Nissan Leaf that's at 50% battery capacity, the charger is going to try and deliver as much power as it can safely into that battery over kind of a curve of charging. Once you start to reach the top of the battery pack, we do start to slow down the charge. And that has to do with the chemical composition of the battery itself. If you think about everything you've ever heard about your iPhone or Android device, they tell you not to leave it plugged in for too long. It's bad for the battery. Something similar happens when we're thinking about EV charging as well. So at the higher end of the spectrum, the EVs charge much slower. As a matter of fact, most fleets only charge their EVs up to around 80% or so. And even if we had the same model year Nissan Leaf or Chevy Bolt in our fleet, they may have different battery conditions. So the charge that's delivered to the vehicle really is individualized, and we feel that that's important to note. This charger comes with both a CCS1 and a CHAdeMO connector. That's really going to cover the US market. CCS1 is just a DC fast charge version of the J1772 that I showed in some previous slides. The CHAdeMO connector is more popular with Japanese style vehicles, even though there are some Japanese OEMs that we've worked with who have brought products to the US market that do use a CCS1 connector. Again, a Tesla could certainly charge on one of these units, again, with that adapter that most Tesla owners keep in the trunk of their vehicle. So something else to point out that's very special about the chargers that we offer in the DC fast charge space is that these units are liquid cooled. If we were to take this unit apart and turn it sideways, you would see across the very top, kind of the area in blue that says Gilbarco Veeder-Root right now, that's where all the sensitive electrical componentry is that delivers the charge to the vehicle. That entire area is enclosed in IP65 rated aluminum cowling. What that means is that is absolutely protected against dust and moisture intrusion. If you think about the life of electronics, dust and moisture are the number 1 and number 2 killers for devices. So by preventing the sensitive electrical componentry from being exposed to those elements, we're extending the life of the charger, and we're also cutting down on the cost of ownership of the charger because of lower maintenance requirements. So this is really a great fit for customers who are looking to add DC fast charge to their fleet. Really at the top of the spectrum is a 175 kilowatt charger that we've just released. This is called a RT175S. It's got the same connection ports as the RT50, but as you could imagine, it's 175 kilowatts instead of just 50. Really, we see this being a fit for fleets who are bringing in those bigger battery packs and have a very short duty cycle to charge. We also see this as a fit for some requirements for grant monies that are available. Some Volkswagen settlement dollars have been really earmarked for high-powered charging, and that's really where this where this unit comes in. Some of the items, again, to note for these units, I mentioned, liquid cooling, lower cost of installation. The unit itself is actually a pretty small footprint. And in some fleet depot environments, that's really important, where you don't have a lot of room to devote to EV charging. You can't take up half a parking space or use up, feet and feet worth of real estate for charging infrastructure. These units do have a lot of flexibility in that space. They also are certainly customizable when it comes to the branding on the unit itself. On the unit that's on the screen right now, everything that's in blue, with the exception of the very front middle panel, which is actually the instruction panel, that's available for custom branding. So if you're a city or a fleet that's very proud of your name, we can actually brand these chargers with your logo so that you can get to share your sustainability goals with those who are using them. So super excited to have that feature set as well. From an installation standpoint, these units have been installed around the globe. So if you think about some of the harshest environments out there, environments where there's no canopy to protect the unit from the rain or the sun, environments where vehicles still need to charge in the snow, as you can see in the center of the screen. We're absolutely capable of performing that type of charging with both our level 2 and our DC fast charge units. And so we're very proud to offer this type of technology to our customer base, and certainly to share it with our sister company through Teletrac Navman and into your considerations for fleet electrification. So I know we've kind of covered a wide variety of topics today, but I wanted to go ahead and sort of open up the floor for Q&A to make sure we still have plenty of time available for folks who may have some detailed questions about EVs. Thomas, I think you had some instructions around that.
Yeah, we got some questions in the chat box. So let me come up on the first one. All right, here we go. Are you currently, or will you plan to offer a turnkey charging as a service business model for fleets? If so, what are the details? We seek to shift hardware/install costs from a CapEx to OpEx and pay-as-you-go, including maintenance.
Yeah, absolutely. So that business model is something that we're seeing more and more of in the space. So we do have partners and distributors who are interested in providing fleets with this type of model. Really, the trade-off that you're going to be making is, instead of purchasing it, as you said, a CapEx, it's going to become an operating expense. You would rely on the partner that we bring to the table to do the site design, perform the installation, take care of the ownership of the charger, also be responsible for any maintenance or repairs required on that charger as well. In return, you would pay for your availability to charge using these units based on a metric that's going to make sense for all parties. So that could be a kilowatt hour, it could be a number of stations, or a flat fee per month. But yes, we do have options to provide that type of solution to our fleet customers. And that's something that I'd be happy to explore. I know that Thomas is going to, there's going to be a share of this presentation at the end of the session. Certainly interested in fielding that question at a kind of a more of a one-on-one level, but great question to kind of kick things off.
Hey Alan, it's LJ here. It looks like I have another question. What are the cost implications of electrifying your vehicles?
Well, so when you think about vehicle electrification kind of across the board, you really do need to break it into some buckets. You've got the physical vehicle itself. So there's going to be a purchase price associated with it. In today's market, as the battery prices continue to drop, that's great, but EVs still are more expensive typically than their counterparts with a gasoline or diesel engine. So to somewhat offset that, there are availabilities for credit dollars that come from the federal government or perhaps from a state or local government. So that can help take the edge off of the price premium on the front end of the vehicle itself. While we think about the vehicle, I mentioned previously, total cost of ownership is a big deal in the space. So since you don't need to perform oil changes or oil filters or spark plugs or any of the other myriad of requirements for a fleet to maintain a safe PM schedule, keep their drivers safe and happy out on the road and not stranded with a broken vehicle, that TCO, because these elements are not required for an EV, that really does cost or cut down on the cost for the life cycle of that vehicle. So that's certainly important to mention as well. Now, if we think about shifting into the fuel of the vehicle, kind of a good national average to use is about 13 cents a kilowatt for energy dispensed. And what that means is, in the case of a Nissan Leaf, you could fill up a battery from completely empty to completely full for around $5 as a good ballpark number. In comparison to taking a vehicle and using even gasoline priced on today's market, you're still going to be spending more on that fuel. So the actual fuel for the vehicle is less expensive. On the flip side, you do need to typically purchase the infrastructure. So the cost of the charger itself can vary pretty dramatically. Level 2 AC chargers, like our Amps2Go product, are typically priced in the mid 3,500s and up, depending on if we're going to do a single port unit and in some options that are available. When we think about the DC fast charge space, these are significantly higher power units that are delivering that energy in a much shorter period of time. What this really means is it's a much more expensive system to purchase. And typically in the fleet world, it's going to require some infrastructure upgrades that need to be coordinated with a utility. So for the DC fast charge side of things, you're certainly looking tens of thousands of dollars to deploy that kind of system at a fleet facility, even more if we're thinking about a high-powered charger. So you do have to kind of break that down into buckets, and those cost implications really do need to be weighed out against an organization's overall sustainability goals. So if you think about your march to electrification or your requirements to have a zero emission fleet, those can be very difficult to think about. How am I going to accomplish this and really get started? So that's where we feel like the cost of the vehicle, the total cost of ownership, the cost of the infrastructure, the cost of the energy and compared to fuel, all those things are carefully considered through an electrification study. So if there are any questions about how to get started with something like that, those are kind of a recap of the places where we can certainly provide solutions.
Excellent. Thank you, Alan. I have another one here. Is there any information you can share regarding EVs entering the OTR trucking space and charging requirements related to those size vehicles?
Yeah, absolutely. Great question. So, the over-the-road market is near and dear to my heart. I started my career as an inside salesperson for a fuel card company, speaking with mom and pop trucking companies, owner-operators who are out there on the road. I've worked with small trucking companies all the way up to some of the largest carriers across the nation. So the over-the-road space is certainly interesting for EVs. To be very candid, I think that cross-country trucking is a difficult fit for electrification. I think that hydrogen fuel cells are really where we're going to see a lot of activity for people who are doing true long-haul trucking. But in the regional haul space, that's really the majority of America's trucking, is that 250-mile or less range. We do see some significant activity coming from folks like Daimler through their Freightliner brand, or Volvo, or some of the other OEMs, and we're in regular conversations with OEMs about what their upcoming products are going to look like. Of course, their job is to sell new trucks, and our job is to sell new chargers. So it makes a lot of sense for the two of us to partner together to perform validation testing to make sure that their vehicle absolutely works with our charger so that we can work with our distributors to help get that deployed out in the field. I do think that this is going to be a really exciting place to see electrification roll because if you look at the figures for emissions, transportation is the #1 source of emissions for on-road activity. Even consumers, not nearly as many CO2 emissions as what we see in the actual transportation space. So there are really some exciting indicators that fleets are going to have the opportunity to move into electric vehicles in the class 6, 7, and 8 space. In addition to that, I would volunteer that because of our extensive relationships with convenience stores and truck stops, we are actively working with the owners of those businesses to take advantage of Volkswagen dollars that are available to make charging accessible in the road market. So thinking about interstate corridors. So we're actively seeing customers in some of the greenest states in the country purchase and install DC fast chargers and make them available for consumers to use. We anticipate to continue to see that model as a solution for the trucking community who is going to need to pull in and charge a vehicle and get as much energy as they can to get back to home base and perhaps finish the rest of their charging at a home base facility. So I hope that gives a little bit of insight into the over-the-road trucking space and what we're seeing in the EV market in that particular area.
Thanks, Alan. We do have another question here. Are there any safety concerns with electric vehicles?
Yeah, so the safety of an EV is really in parity, if not better, than what we see from a traditional ICE engine vehicle. So if you think about the activities that are required to operate the vehicle, it drives the same. It has a pedal that makes it go. It has a brake that makes it stop. Some EVs, like Tesla's, come with their own autonomous systems. I'm not saying I'm an advocate or opposed to those, but they're certainly available on the market. They come with the same safety features, roll cages, airbag protections, things that you would expect and are legally mandated for vehicles to have. When you think about some of the ancillary requirements of operating those vehicles, we feel like, and it's been proven, EVs are safer to fuel than traditional ICE engines. In a regular gas car or a pickup truck, you pull up to the pump and you activate that pump, and all of a sudden you have a nozzle that's dispensing a volatile liquid at roughly 7 gallons per minute on most of our commercial fuel dispensers. If you think about the safety implications there, it's mind-boggling that some consumers are allowed to even touch this equipment. On top of that, you run into an opportunity for perhaps a distracted driver who wasn't paying attention and then drove off with the nozzle actually still attached to the vehicle. That's the reason why we make safety breakaways, but that's certainly another area where there's a lot of potential for disaster. In the case of an EV, when you grab the connection point and you make that connection between the vehicle and the charger, there's no energy being dispensed until the vehicle has performed a software handshake with the charger itself. So in the case of our DC fast chargers, when you grab that port, you're not holding a 480 volt pistol waiting to shock somebody. You could drop it in a puddle and it's not going to do anything. In addition, the vehicle can't drive off while it's still connected to the charger. The battery management system simply will not let the vehicle shift into drive. So from a safety standpoint, there's a lot of implications to exactly how a fleet operates a vehicle, what traditionally fueling looks like today, and the ways that electrified vehicles are really changing some of those day-to-day operations.
Excellent. Got one more question here for you, Alan. It's kind of cool. Is there any new or emerging tech that is on the horizon for electrification that's particularly exciting?
Sure. Well, so I mentioned earlier in the presentation that the chemistry that's being used to manufacture the batteries is getting much better. Really, in the grand scheme of things, we're going to continue to see battery prices drop and drop and drop. I think one of the latest numbers that I saw was something like $100 per kilowatt hour as a projection of where we're going to be just in the next few years. As these batteries continue to get better, batteries have always been one of the most expensive parts of an EV. So if we can cut down the cost of the physical battery itself, while potentially also extending the range on those batteries, the vehicles of today are getting significantly better mile per gallon equivalent on an EV than even some of the predecessors like an early Nissan Leaf or a Chevy Bolt. So the batteries continue to get better, which means that the end consumers in the fleet space are going to see prices of EVs continue to drop. That is certainly exciting in the space. If I could also pull from the slide that I mentioned earlier, the ability to make some clear decisions using electrification studies, these types of studies weren't available before. And when you've got data sourced from a telematics system like your Teletrack Navman program, you know the veracity of that data. So as we run it through the analytics engine and provide a result that says, out of your fleet of 100 sedans, these 20 are excellent candidates. Vehicle 101 needs to be replaced with a regular Nissan Leaf at this price point. 102 replaced with an extended range Nissan Leaf at this price point. That's really compelling. And we're going to continue to roll that into the medium duty, heavy duty space. So we see that as a great opportunity to leverage existing data from sister companies to bring that into the space. So we're very excited about that. I think if I would add maybe perhaps a final note on things that are exciting with technology for EVs, a lot of fleets have been screaming for electric pickup trucks, and the good news is on the horizon. A couple of weeks ago, I made my first and only trip out as a traveling salesman. I went to Lordstown, Ohio for the launch of the Lordstown Motors Endurance pickup truck. They're projecting that vehicle to be available mid-2021. And so we're super excited to see that coming down the pike. Mike Pence, not getting into politics, like him or don't like him, but he was present at that rollout and actually was sitting in the passenger seat of the pickup truck as it was driven on stage. So when the Vice President of the United States is making signals about electrification in the pickup truck space, we can all get pretty excited about that. So I think that's kind of a multi-pronged answer to a simple question about what's exciting with technology in EVs.
Gotcha. Thanks again, Alan. That brings us to a close on the questions. So I wanted to just thank all of you for attending. Thank you very much, Alan, for enlightening us with the information you presented today. Remember, there will be a follow-up email with information relevant to the PowerPoint presentation, recording, as well as further instructions as to how to communicate back with us should further questions come up in your minds as you continue to digest this information. So again, thank you for everyone in attendance and to our presenter, and everyone be safe out there. Have a good day.